Hi, good evening, everyone. I welcome you all and I thank all the organizers for making this platform available for all the participants so that in this entire session of 1.5 hours, we can discuss more about sustainability, green buildings. Without wasting much of the time, I'll start off my slide with this particular slide on your screen. We'll talk about the Constitution of India. As part of the Constitution of India, this Constitution of India contains two major aspects that, as a citizen of the country, what are the benefits that, or what are the rights do we have as an Indian? And it also covers certain aspects that what are the duties that we need to pay towards our country being an Indian. Now, in this particular document, if we just, look at the sustainability component, it says that as a citizen of the country, it is my prime responsibility and duty to preserve and protect the flora and fauna of our country. Now, this is what the Constitution of India says. Now, let's have a look what we eventually do in the name of construction. And this is how we are preserving and protecting our flora and fauna. We are on the verge of deforestation. Our forest areas have now, in the last 2 decades, have reduced to almost 3% to 4%. We have been extensively dumping our forest areas or country yards with dumps, with construction demolition waste, C&D waste. We have converted our rivers into nalas. In fact, Dr. Roshni, just mentioned a case about Mumbai, and this is not just in the case of Mumbai, but you take any tier 1, tier 2 city, and you will find a lot of cities, a lot of the rivers or lakes have been converted into nalas. You talk about Bangalore. Bangalore one used to have thousands of lakes, and now they have shrunken to just hundreds. So this is the scale where we are in the name of construction. We are not caring about the environmental degradation that we are making. So basically now it is high time to revive things back, the damages that we have made, and to make sure that we give something back to our next coming generation. In the process of construction, if we specifically talk about, there are a lot of carbon emissions that eventually take place while we do or we construct any particular building. Now, constructing any particular building, there are a lot of materials which are eventually involved and which are eventually required for the construction of that particular building. Now, from the extraction to the use of that particular product, at every stage we are generating carbon dioxide emissions into our environment. So we need to ensure that that does not go into the disposal and that can be reused. That is the prime motto that we should use. And our codes are also helping us drive to that factor. We have energy conservation building code, which is specifically talking about that how we can conserve energy in our buildings, how we can make sure that by installing the right and the optimum motor, pump, chiller, or any system, any mechanical electrical system into our buildings operations, we could save a lot of cost on our operational cost on our energy savings in terms of energy savings. At the other end, we also have a national building code, NBC 2016, which is the latest one right now, which has been rolled out, and it specifically captures a sector, a sustainability chapter in it, which talks about rainwater harvesting. It also talks about ways of materials that needs to be built. It also talks about window to wall ratio. There are certain other aspects, but when we have these codes in place, why do we require rating? Now, ratings are the driving factors. So the minimum performance benchmarks are certainly something which have been defined in these codes. But the damages that we have already done, they cannot be met with the timelines that we see in the next coming 20, 30 years if we just move with that particular line. So we have to push ourselves towards to make sure that this timeline could be shrunken or could be reduced. So there is where the certification agencies or certification comes into play, which gives you credibility. It verifies against the standard benchmarks and it quantifies that how project resource consumption has eventually taken place. Now, GRIHA, the Green Rating Integrated Habitat Assessment, is basically a tool to design, facilitate construction operation of green buildings and in turn measure the greenness of the buildings which are coming up in India. GRIHA came into existence in the year 2005 and it rates projects from 1 to 5-star certification. GRIHA is the only national green building certification system of the country and it has been endorsed by the Government of India, Ministry of New and Renewable Energies, as the national certification system of the country. In fact, GRIHA has also been mentioned as India's own green building rating system to mitigate climate change in the INDCs, which was submitted in the COP21 summit, which happened in Paris 6 years back. So this is a screenshot of that particular document, which was being released by the Government of India. Now, GRIHA has also got a lot of accreditations, not only from the government of India, but also has been recognized on international platforms by whether it be UN, whether it be UNFCCC, whether it be UNEP or ALGOR. In fact, the government of India's biennial update report on the United Nations Framework Convention on Climate Change, which was published last year in the month of February, clearly states that the numbers which are defined in the GRIHA are the only numbers which are going to be counted or taken into account for the climate mitigation or for the carbon estimations. GRIHA comes up with a portfolio of a few rating variants, which are broadly categorized into two rating variants. One is for the new building segment, other one is for the existing building section. Now, in new building section, we have primarily four major variants. One is SWAGRIHA, which is basically for projects which have built up area below 2,500 square meters. We have the next variant, which is GRIHA, which is the main rating variant of R. And we have recently launched the new version update of this, GRIHA version 2019. Although it was launched at the end of the year 2019, and due to COVID, we had to certainly extend our timelines. But now any project which is getting registered with GRIHA is certainly getting their certification under version 2019. We have introduced a lot of new concepts such as life cycle costing, life cycle cost benefits, life cycle estimations, water performance index. There are a lot of quantification parameters which have been added in this new version. We have another rating variant which is called GRIHA LD, GRIHA for larger developments, which is applicable to projects which have built up area above 50 hectares. And this applies for large scale developments which are coming up in the country, whether you take any IIT campus, whether you take any IIM campus, or large scale townships which are coming up in the country, they are all going in for GRIHA LD certification. We also have a certification specifically for the affordable housing segment. We all know that the government of India has launched a scheme, PMA, Pradhan Mantri Awas Yojana scheme, and to make sure that housing for all is sustainable at the same time affordable, GRIHA for affordable housing rating system was launched. We also deal into existing buildings where we certify commercial buildings with 2,500 plus square meter of area under the existing building category. And we also have a specific program for schools, GRIHA for existing day schools. It is not just a rating, but it is also a module that we have developed so that students can understand sustainability from grassroots level. We have also devised a certification system, GRIHA for cities, and this is in line with the smart city program, the 100 smart cities which are coming up in the country. This program, this certification system has been designed to look at that. Now, quickly going on with the theme of today's discussion, which is basically on how construction techniques, technologies are making the construction the payback periods much smaller. So I'll go through some of the case studies of GRIHA certified projects or registered projects, and how they are or what steps that they are incurred during the construction phase or post construction phase to make sure that their material resource consumption is something which could be optimized. So I'll talk first about IIT Kanpur. This was the first 5-star certified project of GRIHA. Now, in this particular project, you can see, first of all, the design of the building has been done in such a manner so that there is minimal tree cutting which has been done. You will find that a lot of trees has been planted very close by to the building, but these trees were there, existing trees, and the building has been designed so that they do not hamper the trees in around them. Now, before moving on to the construction of any particular building, the project team, what they did, they defined their boundary. So this blue color boundary that you see was the boundary which was the site which was allocated for the construction of this particular building in the IIT Kanpur campus. Now the project team, further subdivided or defined a red line boundary to make sure that their entire construction and material storage and construction activities are only going to be defined in this red zone, and they are not going to touch upon the zones which are there on the northern side and as well as on the southeastern side. Now you can also see to make sure all the trees which are there on the site are preserved and protected. They used empty cement bags to make a barrigation all along these existing trees. At the same time, the 3-meter high barrigation was also created using these empty cement bags, which is a waste. Now, there is a lining that you see here, brick lining, which has been done. So basically, this is a sedimentation pit that the project team has constructed. Now, this sedimentation pit was constructed at a low-lying area as per the contours of the site. And first, at the initial during construction phase, this particular area was utilized for sedimentation pit, and later on, this area was converted into a water body, which is right now there at the site, which was part of their passive design architecture, which makes sure that the microclimate of the zone is cooler. They also made sure that during the due course of construction, there is a drainage channel which leads to this sedimentation bit, which we have seen in this particular slide. We'll now talk about a project which is Z-Earth Village. This particular bungalow was constructed in Bangalore, and they have used GGBS in the RMC. There are hollow concrete blocks which have been used for the wall construction. In fact, they have also used C&D based materials in certain internal walling applications. 40% reduction in embodied energy from the base case has been recorded. They have also used bamboo for flooring. Bamboo is a rapidly renewable wood, which is certainly recommended for usage in your flooring or paneling purposes, because the rate at which it grows is very fast, since it is categorized under a grass category. It is the tensile strength, the strength, the durability of this particular material is very high. So compared to Italian marble, making your floors with bamboo was a much cheaper and a sustainable option. The doors and window panels which are made in this particular project have been made using engineered wood, and 73% of the interior finishes were low energy materials which were used in this project. Suzlon Manath project, another 5-star GRIHA project in Pune, use post-tensioning technique for saving almost 50% of steel and concrete consumption during construction. They use non-load bearing walls and modular partitions, and they've also used engineered wood for their internal paneling and partition work. They further used low VOC paints in their interiors to make sure that the indoor air quality is maintained. Suzlon Govardhan Eco Village is another very good example to showcase over here. Now, this entire campus is a net zero campus, and this was the first project in GRIHA to score 100 out of 100 points. And they have done a lot of measures on site to make sure that their embodied energy and their carbon emission numbers are very, very minimal. Now, these cement stabilized earth blocks were constructed on site and they were sun dried. They've used sugarcane thatches for making their roofs. The doors and windows are made from reused wood, so waste wood which was lying at the scrapyards. They collected them, they refurbished it, then they used it for the construction of their doors and windows. Tiles which are used for flooring in this particular project are all recycled waste tiles or are made from C&D waste. They have also used precast arches as a technique to make sure that they can get larger spans without incurring more usage of usage of steel or concrete. So they have replaced columns and beams with these precast arch panels. They have further make sure that by using these cement stabilized earth blocks, their embodied energy consumption is just 1% of a regular red clay burnt brick wall. Red clay burnt brick. So a red clay burnt brick usually has an embodied energy number of almost 72 megajoules of energy per kg, whereas as compared to these cement stabilized earth blocks which were constructed on site, they had an embodied energy number of just 0.27 megajoules of energy per kg. They have also replaced sand with C&D waste queries, these fine particles. Further, there is another project which we have certified in Indore, where the entire project, they have used PPC for 100% construction of their structural and plaster masonry mortar work. They have again used low VOC paints to make sure that the indoor air quality is maintained. Further, they have demonstrated an embodied energy reduction of almost 17% by using AAC walls for the construction of their exterior walls. Almost 75% of the floor areas are made with low energy materials. So these are the rough finished quota stones which have been applied for the flooring. Now these quota stones that you see, these are not being bought from the quarries. So there was the demolition of a project which was going nearby to this particular site, and what the architect and the project team did, they went to that site, they took out the stones from there and they got it and they fixed it up in their particular project. This entire door that you see is entirely made out of waste. They have used these waste wooden buds which were there available at a saw cutting station, and in fact the handle that you see is also a waste wood which was refurbished, and this entire door was constructed. There are a lot of projects coming up in Delhi where redevelopment projects are going on. Kidwai Nagar East is one of the redevelopment project which has recently been completed. So it was a very massive construction which happened, and it took almost 7 years to build up this particular project. Now there were existing structures, G+1 structures, which were there, which you can see from the photographs. So all these structures were demolished, and the debris which was generated was reused, and C&D waste blocks were constructed on site, and these C&D waste blocks were utilized or were used for the construction of walling blocks in the project. The same ways, other projects which are right now going on in Delhi, whether it be Narojini Nagar, whether it be Sarojini Nagar development projects, they are all following the same technique which was followed there. In fact, the Pragati Maidan demolition also happened 3 years back, and now the convention center is right now coming up. Here again, the same technique is followed. All the construction debris which was being generated has been reused by creating C&D waste blocks. The steel bars which were there, the reinforcement bars which were there, they have been melted and they have been mixed up with the virgin steel bars, and these recycled steel bars are now again have been reused for the construction of the new convention center which is coming up in Pragati Maidan. IIT Tirupati campus is another GRIHA project which is registered under the GRIHA LD category. Now in this entire project is getting constructed from C&D waste material, where just 100 kilometers away from Tirupati in the Chennai city, in the outskirts of Chennai city, there has been a precast setup which has been established, where C&D waste is used as one of the major materials, and precast panels are getting manufactured there, and they are getting imported on the site, and through these precast panels the construction is taking place in the IIT Tirupati campus. Apart from that, Siona is one of our Pune residential projects in Pune, where the project team has fixed up fly ash brick making machine. They have installed a fly ash bricks making machine on the site, and fly ash bricks were constructed on site. They were sun dried and they were used on the site to make sure that the embodied energy reduction of the project can be achieved. International Tech Park in Gurgaon, they have used AC blocks as they have used AC blocks for the walling construction, whether it be internal or external. At the same time, they've also gone in for PT slabs, post-tensioning slabs, which is further reducing almost 30% consumption of steel as compared to conventional case in this particular project. Bihar Museum in Patna is another very good example where the project team has used prefabricated panels. Now these panels are made up of PPC, where there's almost 35% content of fly ash in them, and these precast panels have been used for creating their walls, their internal partitions. There are a lot of places where flat slabs have been constructed, which further ensures reduction of concrete and steel in the project. Overall, the project has been able to reduce the consumption of steel and concrete by 35% as compared. Gratitude Villa, another project in Pondicherry that is very recently certified by us. In this particular project, they have gone in for using recycled steel. They have used 69% of GGBS in the construction of their slabs, their columns, their beams, and just 31% of OPC has been used in this project. The project has been able to curb 50% of embodied carbon content numbers. They have used reclaimed timber for the construction of their doors and window frames. They have also used the technique of rat trap bonds using fly ash bricks, which further ensures a very good R value. So as compared to a conventional brick, the R value of a rat trap bond with fly ash bricks gives you an R value of almost 9 to 10. Further screening has been done by using spray plasters, which further reduces the wastage of plaster in the project, and this is certainly done with PPC, which has almost 30% content of fly ash in it. Now, in terms of the reduction, GRIHA, with its 700 rated projects till now, has been able to achieve a carbon reduction of almost 83 lakh tons of CO2 emission per annum, and almost an energy savings of 29 lakhs of megawatts of energy has been saved every year. Through GRIHA, we have been able to ensure that almost 2,66,000 trees have been planted in the country. Almost 28,000 trees have been preserved till now. And we are also making sure that this number increases. Thank you.